In 1950, a brilliant mathematician named Alan Turing posed a question that would ripple through the decades. Can machines think? It wasn't just a question, it was a challenge, a spark. While the world was recovering from war and discovering the first electronic computers, Turing was already imagining a future where machines could engage with human intelligence. His vision became the foundation of artificial intelligence. This was the moment a new Odyssey began, the AI Odyssey. At the time, intelligence was something we believed only humans could possess. Machines could compute numbers, yes, but could they reason? Could they understand? The world was skeptical. Scientists faced a daunting challenge: how to formalize and replicate human reasoning. Early approaches struggled. They lacked the flexibility, adaptability, and nuance of the human mind. The idea of teaching a machine to understand language or see images like we do, it seemed almost magical. But pioneers kept pushing. From the perceptron to symbolic logic systems, researchers experimented with ways to mimic the brain. They built programs that followed rules, systems that stored knowledge. They built the first chatbots, like Eliza, which could simulate a therapist using scripts. They even tried to encode expert knowledge into rule-based systems. Progress was slow and uneven, but something was taking shape, a blueprint for machine intelligence, however fragile. Fast forward to today, and AI has exploded into every part of our lives. It writes our emails, drives our cars, recommends our music, and even creates art. AI doesn't just calculate, it composes, it generates, it understands. Models like GPT-4 can answer complex questions, simulate personalities, write code, and solve problems in ways we once thought impossible. We no longer ask, can machines think? We ask, what can they do next? The real revolution began in 2012, when a deep neural network called AlexNet won the ImageNet competition by a massive margin. Suddenly, machines could see. They could recognize cats, cars, people better than ever before. The secret? Layers, deep learning. By stacking neurons and training them on massive datasets, we taught machines to extract meaning from noise. This wasn't programming, it was learning, and it changed everything. Then came the Transformer in 2017, a model that understood not just words, but context, relationships, patterns. It was a new architecture based on attention. Soon after, GPT-3 and GPT-4 astonished the world with their ability to write essays, poems, and even jokes. These weren't just tools, they were creators. With billions of parameters, they embodied the language of humanity, trained on everything we've ever written. In 2022, AI became personal. With the launch of ChatGPT, millions of people around the world spoke to an AI, many for the first time. It was fluent, helpful, even funny. It changed classrooms, businesses, daily life. People used it to brainstorm, write resumes, explore ideas. It was no longer a distant lab project. AI was in our pockets, and everyone had access. But what happens when AI doesn't just respond, but acts? In 2024, a new wave of AI agents emerged. These models could plan, execute tasks, use tools, browse the web, write code autonomously. They were no longer just conversational partners, they were collaborators. Paired with real-time learning, RAG systems, and multimodal inputs, AI began to reason and adapt live, like an evolving intelligence. So, what's next? We're entering the era of self-improving AI. Systems that learn how to learn, that design better versions of themselves. AI is creating new art, new science, even new knowledge beyond human reach. And as we step toward artificial general intelligence and beyond, the question returns, not just what machines can do, but what we choose to become with them. This isn't just a story about machines, it's a story about us.
That powerful move length about 90 seconds.